Good morning, grade 9s. This lesson, first lesson, is on electron structure of atoms and why it is important, with some basic information. Why are electrons important? Electrons determines the chemical properties of the elements. So they determine the stability of the element, and stability means they are not reactive. They are inert, like the noble gases, are inert. That's another way to say they are stable, they do not react. They also determine the reactivity of the elements, like how readily, how fast they react with other substances, like the alkali metals. They are very reactive. They also determine the ratio between the atoms in a compound, like why water's got 2 hydrogens and 1 oxygen. Right. The second thing is to know where the electrons are found. They are found in what scientists call orbitals. So the next slide is going to describe some orbitals. There are s orbitals. Now, s orbitals are spherical. And if you look at the lesson that I've posted to you, and they use hydrogen as an example because hydrogen's got 1 electron. The atomic number is 1. So it means it's got 1 electron. Now, scientists discovered that an electron moves around the space around the nucleus. So hydrogen will have in its nucleus a proton. So let's symbolize the nucleus like that. Then if you would take a photo of the electron, you might find the electron there. If you take another photo of the electron might be there. If you take a third, and so thousands of photos of this single electron was taken, and they discovered that this electron moves around the space in a circular, like a soccer ball, 3-dimensional circle. So that is what you'll see pictured on the slides. If you superimpose, if you put one photo of the electron on top of another, you will find a spherical shape around nucleus in which electron moves. And they call that the s orbital. The next type of orbital that you need to know, they are p orbitals. So if that electron of hydrogen is found in a p orbital around the nucleus, the electron, and you could take photos of this electron. This electron would be and superimpose these photos that you take of the electron. You will see that the electron moves in a space that looks like 2 teardrops joined at the nucleus. So this is called a p orbital. Its shape looks like 2 teardrops joined at the nucleus. So p orbitals are lobe-shaped. Unfortunately, we don't say that they are teardrop-shaped. Now, p orbitals, there are always 3 together. So you'll get another one. It's called, okay, let me start over there. This, in mathematics, the vertical axis is called the y-axis, so that's a py orbital. In maths, the horizontal axis is called the x orbital, so that is the px orbital. And coming out from the back to the front, that would be called the z-axis. Now on paper it's difficult to draw something coming from the back to the front, so a three-dimensional, those of you doing technology should have an idea of three-dimensional. So the shapes are not important for grade 9s, but to know that there are s orbitals and p orbitals, that is important. Now, these orbitals, they form energy levels in which the electrons are found, and we simplify the whole idea of s and p orbitals and energy levels by drawing an Earthbound diagram. Which means it's the build-up of the electron structure. Sorry for my crooked line here. So we draw the y and the x, and the y is called the energy. So on the y-axis we're going to draw the energy levels. So you've got 1 energy level, 2 energy level, 3 energy level, 4 energy level. We only go up to 4. And the orbitals that we are interested in are the s and the p orbitals. So your first energy level, this one, has 1 orbital, and it is the spherical 1s orbital. The second energy level has 4 orbitals. It's got the 2s, it's called the 2s because it's in the second energy level, and it's the shape s orbital, the spherical orbital. Then the p orbitals, because of their teardrop-like shape, their lobe shape, they have a higher energy level, energy state, but they don't go into the next level. They're still in the second energy level. So this would be your 3 p orbitals, but they are called the 2p orbitals because they're in the second energy level. So you could, if you want to, say this is the px and the py and the pz orbitals, okay? But we draw them as circles or blocks. We don't draw them like they actually are. Then the next lot is energy level 3, where we have a 3s orbital and the 3p orbitals. And we just call them 3p orbitals. We know that they're the px, py, pz orbitals, but that's not of importance right now. Then the last energy level we go up to is the 4th energy level, and we only draw in the 4s orbital. We're not going to look at a more complicated situation. If you want to, you're welcome to look at that, but that is up to where we go. Now, I'm going to move on to the next video to explain how the electrons are distributed. Thank you for watching.